Here we're going to cover export policies for our NAS protocols, and strap yourself in because this is going to get quite involved. Export policies and the export policy rules on those policies enable the administrator to restrict access to volumes and qtrees. We can grant no access, read-only, read-write, or superuser access based on the client, the end host's IP address, the protocol they're using to authenticate, so NFS, the version of NFS and/or CIFS, and their authentication type, which can be none, sys, which is the local user database, Kerberos, or NTLM. On top of our export policies, we can also set standard Unix or NTFS permissions on our files and folders. An export policy with export rules must exist on the SVM for NFS clients to access data. So it's mandatory for NFS clients. By default, export policies do not apply to CIF shares, but we can turn it on for CIFs as well. Export policies can be specified at the volume or the qtree level. Qtrees will inherit the parent volume's export policy by default, but if you want, you can override it at the qtree level. Each volume has only one export policy. The same export policy can be used on multiple volumes or qtrees if you want to give them the same client access, or different export policies can be used on different volumes or qtrees to give them different client access. Export policies are containers for export policy rules. So we configure an export policy. It contains rules. It's the rules that define the access rights. If a client does not match any rule in the export policy, then access is denied. So if an export policy is empty, no rules in it, then all accesses are going to be implicitly denied. When you create your SVM with flexible volumes, the storage system automatically creates a default export policy called default for the root volume of the SVM, which has got no rules in it, so there's not going to be any access. You must create one or more rules for the default export policy before clients can access data on the SVM. You can also create custom export policies if you want to as well. So you can use the default. If you do, you're going to need to edit it because it's got no access by default, or you can create your own custom policy. So you're going to have one export policy applied to a volume. Inside that policy, you can have multiple rules. The rule order is dictated by the rule index number. So rule 1 is read first, rule 2 is read second, and so on. If a rule matches a client, the permissions of that rule are used and no further rules are processed. You configure export rules to determine client access permissions using the following criteria: the file access protocol, NFS or CIFS, the client identifier, the IP address for coming in from, and the security type, how they're authenticating. All three criteria must be specified in each rule, and I'm going to cover each of those three types in depth on the next few slides. So the first one was the file access protocol. The options that we specify there are we can select all NFS versions, meaning the client came in over NFS, we don't care which version of NFS they're using, or we can say NFS version 3, or we can say NFS version 4.x, or we can say CIFS. You can enable both NFS and CIFS in the same rule. The second thing to specify is the client identifier. Our available client identifiers are, we can use the domain name, and when we enter this, precede it by a dot. For example, .example.com. We can specify the client's host name, an IPv4 or IPv6 host address, an IPv4 subnet using slash notation or subnet mask. So for example, 10.10.10.0/24 in slash notation, or 10.10.10.0 space 255.255.255.0 for the same subnet using a mask instead. If we wanted to match all IPv4 addresses, we would use 0.0.0.0/0. We can also use an IPv6 subnet with slash notation, or a net group when we specify a net group, say the name preceded by an @ symbol, for example at netgroup1. So the client identifier does what its name says, it's identifying the client that is requesting access. The last thing to specify is the security type. Clients which match the file access protocol and the client identifier in the rule are granted read-only, read-write, and/or superuser access to the system based on their security type, meaning the way that they've authenticated, which I'll cover in detail on the next slide. Read-only, read-write, and superuser rights are granted separately in our rule. Multiple, comma-separated security types can be specified in the same export rule. If we use any and none, which you'll see in a second below, they're always used on their own. So the different types, we can say Kerberos 5, so the client was authenticated by Kerberos 5, or we can use Kerberos 5i, or we can say they were authenticated using NTLM, or we can say they were authenticated by type sys. Sys means it's using local accounts. Any means any client that matches the protocol and client identifier can access the data regardless of security type, meaning we don't care how they authenticated. Type none can be a bit misleading. It doesn't actually mean that the client will not get access. If we want to configure the client will not get access, then use the option down at the bottom there, which is never. If we say never, a matching client cannot access the data regardless of security type. So what does none do? Well, if listed alone, clients with any security type are granted access as anonymous, meaning client, it doesn't matter how they authenticated, like Kerberos or sys or NTLM, they're going to get granted access as the anonymous user. We're going to talk about the anonymous user coming up soon as well in this lesson. If listed with other security types, clients with a specified security type are granted access, and clients with any other security type are granted access as anonymous. For example, if we said on the same line, sys and none as well, then users who authenticated with type sys will be authenticated with their user ID. Users who authenticated with any other authentication mechanism will be given the anonymous user ID. If that doesn't make sense yet, don't worry. We're going to be covering the anonymous user in more detail later in this lesson, and I'm also going to give you some examples so you can see how this all works. There's 3 possible access levels in our export rules: read-only, read-write, and superuser, which is used for clients presenting with user ID of 0, which is typically used by root. We're also going to cover the superuser access level in detail later in this lesson as well. Access level by security type is evaluated in that order. So the export policy will check first, do they have read-only access? Then do they have read-write access? And then do they have superuser access or not? So you need to be careful with how you configure rules, because if, for example, you granted a user read-write access, but you didn't grant them read-only access, then they wouldn't have any access at all, because read-only is checked first. If they don't get read-only access, then the system will stop checking there. Let's have a look at that in a bit more detail. So for a client to get an access level of normal user read-only, then the read-only rule must match their security type, meaning the way that they authenticated. For them to get read-write, then both read-only and read-write must match their security type. So if we'd only set read-write, they're not going to get access. We need to grant them both. For a client to get access level of Superuser read-only, then they need read-only and Superuser to match the client security type. And for a client to get Superuser read-write, then we're going to need all three: read-only, read-write, and Superuser. So remember, you need to specify the protocol that the client is using, the client identifier, which is the IP address they're coming in from, and the security type, which is the authentication mechanism they're using. So our first example here, the protocol is NFS version 3. The client match is matching clients from the 10.1.16.0 network, and our security type, we've got a read-only rule of any, meaning we don't care what authentication type they're using, so they'll all get read-only access. And the read-write rule, we're granting that to users who are authenticating with Kerberos version 5 or NTLM. So let's say that a client at IP address 10.1.16.207 sends an access request using NFS version 3 and authenticates with Kerberos version 5. And another client on 10.1.16.211 also sends an access request using NFS version 3, but it authenticates with AlphaPrep. The client access protocol and IP address matches for both clients. They're both using NFS version 3, which is what we specified as a protocol in our rule, and they're both on the 10.1.16 network, which is what we specified in the client identifier. The read-only parameter allows read-only access to all clients that match the protocol and client identifier, regardless of the security type they authenticated with. Therefore, both clients will get read-only access. However, only client number 1 will get read-write access because it authenticated with Kerberos. Client 2 authenticated with AlphaPrep, which is not granted in the read-write rule. If we had another client at IP address 10.1.17.10, it would get no access unless another rule matches, because it does not match the client identifier. It's coming in from a different subnet. Next thing to cover in more detail is clients with unlisted security types. This is where we're going to talk about the security type of none and the anonymous user. The security type, as we've been covering, is how the client authenticated. For example, Kerberos version 5, NTLM, or AlphaPrep, which is using the local user database. When a client presents itself with a security type that is not listed in an export rule, or if the client is not authenticated at all, which would count as security type of none, you as the administrator have the choice of either denying access to the client or mapping it to the anonymous user ID instead. By default, the client is going to be denied access, so you have to explicitly allow this. You can use the option none to grant access to that anonymous user, which has got the username of Anon. The -anon parameter in our export policy rules determines what user ID is going to be assigned to those clients that you do grant anonymous access to. So the anonymous user will be assigned a user ID. That user ID will need permission to the files and directories to be able to use them. Our export policy is used in conjunction with our standard Unix permissions. For a client to be able to get access to the files and directories, it needs to pass the export policy, and it needs to be granted by the Unix permissions as well. So the different user IDs we can use for the anonymous user. We could use a user ID between 0 and 65533. In that case, the client access request will be mapped to that anonymous user ID that you specified, and it will get access depending on the permissions configured for that user. We can use user ID 65534. In this case, the client access request is mapped to the user PC user. When you enable NFS on an SVM, a user with user ID 65534 and username PC user is created by default. One of the uses for the PC user is for multi-protocol access from Windows clients that we're going to be talking about later. That's why it's called PC user. If you do use user ID 65534, then again, the client will get access depending on the permissions configured for that user ID. If you enable the anonymous user by using the none security type, then anonymous users will by default be mapped to user ID 65534. Note that this is different than what happens with normal standard Linux clients. They will typically map 65534 to the user nobody. It's different on our NetApp system. Alternatively, we could use user ID 65535. The access request from any client is denied when mapped to this ID and the client presents itself with security type of none. And the last point on this page, the access requests from clients with user ID 0, so root, is denied when mapped to this ID and the client presents itself with any other security type. We'll be talking about root access later in this lesson. So let's look at another export rule example. Here in our rule, we've specified the protocol is NFS version 3. The client match is 10.1.16.0. So the protocol and client match is the same as what we had in the last example. But now the read-only rule is sys and none, and the read-write rule is any. And we've specified that the user ID for the anonymous account is 70. A client at IP address 10.1.16.207 sends an access request using NFS version 3 and authenticates with Kerberos version 5. Another client with IP address 10.1.16.211 sends an access request also using NFS version 3, but it authenticates with auth/sys. So those first two clients were doing the same as they did in the first example. And we have a third client at 10.1.16.234. It sends an access request using NFS version 3, and it did not authenticate. As we covered earlier on, the read-only rule is processed first, then the read-write rule, and then the superuser rule if there is one. We don't have a superuser rule configured here. Clients number 1 and number 3 get read-write access as the anonymous user with user ID 70. Looking at our read-write rule, it says sys and none. So clients who authenticate as auth/sys will get read-only access with the user ID that they authenticated with. Users who authenticate with any other method, that will match the type none, so they will be granted read-only access as the anonymous user. So the second client, it authenticated with auth/sys, so it would get read-only access with its user ID. Clients 1 and 3 did not authenticate with auth/sys, they authenticated with different methods, so they will match none, and they will get the anonymous user ID, which is 70. Then we evaluate the read-write rule, which is any, meaning any client which was already granted access by the read-only rule will get read-write access with the user ID that was granted by the read-only rule. So clients 1 and 2 get read-write access as the anonymous user with user ID 70, and client 2 will get read-write access with its own user ID. So the final effective permissions will be that clients 1 and 3 get read-write access as the anonymous user with user ID 70, and client number 2 will get read-write access with its own user ID. Let's check another example. We're using the same protocol, NFS version 3, and the same client identifier, 10.1.16.0 network as all the other examples. And in all the examples now, the clients that we're talking about are going to match that protocol and client identifier. Here for our read-only rule, we've said sys and none, and for the read-write rule, we've said none, and the anonymous user is being mapped to UID 70. 10.1.16.207 sends an access request using NFS version 3 and authenticates with Kerberos version 5. 10.1.16.211 sends an access request using NFS version 3 and authenticates with auth/sys. And 10.1.16.234 sends an access request using NFS version 3 and did not authenticate. So the way that the three clients are coming in are the same as in the last example. What has changed is the rules here. Going back to the previous example, we had a read-only rule if sys and none, and a read-write rule of any. Here, in example 3, we've got a read-only rule of sys and none, the same as before, but now the read-write rule is none. As always, the read-only rule is process first. That said, sys and none. Client number 2 authenticated with sys, so it will get read-only access with its user ID. Client number 1 and 3 authenticated with Kerberos and did not authenticate, so they will match the none statement in the read-only rule, and they will get read-only access as the anonymous user of UID 70. Next up, we evaluate the read-write rule, which says none. Now remember, in the last example it said any, so any client that managed to get past the read-only rule would get read-write access with the user ID that it had after the read-only rule. Here we've said read-write rule of none, and this is only evaluated against clients that already passed the read-only rule. Client number 2 authenticated with type sys, so it does not match the read-write rule, so client number 2 ends up getting only read-only access. Clients number 1 and 3 do match the read-write rule of none, so they will get read-write access as user ID 70. Okay, the last thing to cover here on this topic is superuser access requests. Clients may attempt to access the system as the root user ID 0. This is obviously dangerous from a security point of view because root is the superuser and can do everything on the system. So by default, clients presenting with user ID 0 will be mapped to the anonymous user. However, you can specify the superuser parameter in your export rules to change this. The following are valid options for the security type, meaning the way the client authenticates in the superuser parameter. We can say any, Kerberos 5, NTLM, sys, or none. None is the default setting if you do not specify the superuser parameter in the export rule. So you saw those example rules we were looking at earlier. We didn't specify the superuser parameter there, so they would get the default of none. When a client presents his user ID and the superuser parameter is not set, the default is none and the user will be squashed to the Anon User ID. When a client presents his user ID 0 and the superuser parameter is set, if the superuser parameter and the client security type match, then the client will get superuser access with user ID 0. If the superuser parameter and the client security type do not match, then the client gets access as the Anon User ID. This is regardless of whether the read-only or read-write parameter specifies the option none. So that can be a bit confusing. Let's have a look at some examples again to clarify that. So export rule example number 4, we're using the same protocol and client match as before. Here we've specified a read-only rule of any, a read-write rule of Kerberos 5 and NTLM, and the anonymous user is being mapped to UID 70 again. 10.1.16.207 with UID 746 sends an access request using NFS version 3 and authenticates with Kerberos v5. 10.1.16.211 with UID 0 sends an access request using NFS version 3 and authenticates with sys. As always, we evaluate the read-only rule first, and it's matching on security type of any. Client 1 passes the read-only rule and retains its user ID of 746. Client 2 will also pass the read-only rule, but because it came in as user ID 0 and we haven't specified the superuser option, it's going to get squashed down to the anonymous user. So it will get read-only access, but as the anonymous user UID 70. Next thing we do is we evaluate the read-write rule, which is set to Kerberos v5 and NTLM. Client 1 passed the read-only rule with UID 746. It also passes the read-write rule because it authenticated with Kerberos, so the effective permissions for client 1 will be read-write with UID 746. Client 2 does not match the read-write rule because it authenticated with offsys, so it doesn't get read-write access. It gets its read-only access as the anonymous user ID 70. And a final example where we can see where we are using the superuser option. Protocol and client match, the same as in all the other examples. Here, read-only rule of any, a read-write rule of Kerberos and NTLM. So if we look back at the previous example, the read-only rule and the read-write rule are the same. But now we also specify the superuser option with security type Kerberos 5. Again, the anonymous user is being mapped to UID 70. A client at IP address 10.1.16.207 with UID 0, so coming in as root, sends an access request using NFS version 3 and authenticates with Kerberos version 5. Client at 10.1.16.211, also with UID 0, sends an access request using NFS version 3. It authenticates with offsys. Looking at the first client, the read-only rule is any, so it will be granted at least read-only access. Then the read-write rule is Kerberos 5 and NTLM. It authenticated with Kerberos 5, so it also passes the read-write rule. And finally, the superuser rule says Kerberos version 5. It did authenticate with Kerberos version 5, so the effective permissions for the first client will be read-write and superuser access is user ID 0 because it passed all three. Looking at the second client, again the read-only rule is any, so it will get at least read-only access. The read-write rule is Kerberos 5 and NTLM. It did not authenticate with those methods, it used offsys, so it's not going to get read-write access. It could maybe still get read-only and superuser access though, but superuser is set to security type Kerberos 5. It didn't use Kerberos 5, it used offsys, so it's not going to get superuser access and it's going to get squashed down to the anonymous user ID. So the final effective permissions for client 2 are read-only access as the anonymous user ID 70. Okay, we got through it. You are now export policy Jedis. Last thing to tell you is about some commands we can use to help verify what's happening. By default, you cannot list all of the exports that are available on the NetApp system from clients. You can mount them, but you need to know the name of the export to get there. If you want your clients to be able to list the exports that are available, then on the NetApp system, use the command vserver nfs modify, then the name of your vserver and show mount enabled. Then from your client, you can enter the command showmount -e and then the IP address or hostname of the LIF, and you will see all of the exports that are available on that system. Another command that can be helpful is vserver export policy check access, then the name of your vserver, and then client IP, the IP address that the client is coming in on, and then volume, the volume that they're accessing, authentication method, the security type, protocol, then the access type that you want to check if they're going to have or not, read-only, read-write, or superuser. You can also optionally specify the qtree. This command will tell you if that client would be granted that access or not. So it's useful for troubleshooting your export policies.